Okay, I thought we'd start with a quote this time. The best preparation for tomorrow is doing your best today. I like that. So we're still looking at that essential question: can a system of linear equations have no solution, infinitely many solutions? And we looked last time that it could. It could have one solution. That's when they intersect, two lines intersect at one point. No solutions where they're parallel, they never touch, they're forever alone. And the third option would be infinite many solutions. That's when the line is the same line. There's three ways you can tell if a system is has an answer to one of those, and that's by graphing, substitution, or elimination. Now, everything I've said up to this point should be review if it seems kind of fast. So we looked at last time some problems, and they came out parallel, and the reason they came out parallel is they had the same slopes but different y-intercepts. Or another way to say that is they have the same m's but different b's. So now we're going to try another equation to see if we can get a different result out of the three. So to solve the system of linear equations, and I went ahead and wrote them down here, and I'm going to use graphing. Remember, one of the three ways is graphing. So let's go ahead and do that first. So it helps me to graph if I first solve for y. This one's really easy to do that with. Positive 2x to both sides. Bring down the y equals 2x plus 3. And looking at this one, it's pretty easy to solve for y also. I'll add a positive 4x to both sides. Bring down the 2y equals 4x plus 6. Divide both sides by 2. And we have our answer. Now, some of you may observe something at this point already about the two equations that might already give you the answer if it's parallel, or if there's one point where they intersect, or if they're the same line. But let's keep moving on. I went ahead and rewrote these equations on an ordered pair. The top one's m was 2, which we'll write as a 2 over 1, so we have a rise over run. And the b was a 3. So we'll start at 3, and we will do rise over run. We will go up 2 over 1, up 2 over 1, up 2 over 1. And if I wanted to, I could do it in reverse, down 2 over 1. I'll connect my lines, drawing one continuous line, and that's the answer. Well, we see that the other equation has the same m and the same b. They're the same equation. So, of course, that line would be on top of the other line. We would start at the same point, which is b equals 3. We go up 2 over 1, up 2 over 1. We would just draw a line on top. So when given our three choices, what would this one be? Well, it would be infinite many solutions because the lines are the same. In other words, whatever there is for x, that answer would also be true for y. Whatever it is for one line, it would be for the other line. So here's the same equation we just did, but let's do it through the addition method, or the elimination method. The old textbooks used to call it addition. So in order to do the elimination method, you need opposite variable terms, right? So I'm just going to go ahead and change this negative 2x to a positive 4x. So the variable terms for the x are opposite. I'll do that by multiplying by a 2. So we'd have a negative 2, because a negative times a negative would make it positive. And we'll add them up, and we'll see that, oh yeah, the x's get eliminated, but the y's do too. Actually, everything gets eliminated. And since this is always true, that 0 equals 0, it means that the answer is infinite amount of solutions. In other words, whatever you put in for x in one of these equations, it will also be, you'd get a resulting y. Well, that same x would get the same resulting y in the other equation, because they're the same equation. You could also have got that same answer by substitution. This is the same equation we just did. I just have it already solved for y for one of them to save some time. So I'll rewrite this one, a negative 2x plus, but instead of a y, I'll substitute the values in, which is 2x plus 3 equals 3. Well, you can see that these cancel out. 2x and a negative 2x is 0. And then we see that 3 equals 3 is always true. So all the three ways that we've tried it confirms that there's infinite many solutions to this problem. Your turn. I want you to go ahead and try this. 5.4a, title it in your journals. And I want you to try question 1, 3, and 4 using any of the three methods we talked about. Also, it's on page 255 in your textbook. Some are set up, though, for one method over another. Like this one might be easier to do substitution because you already have a y by itself, whereas this one might be easier to do the addition or elimination method because the x is in standard form. You know, the x's and the y's are already above each other. So it's up to you to decide. Okay, last problem I'm going to try to squeeze in here is this word problem. It says the perimeter of a trapezoidal piece of land is 48 kilometers. And it gives you the dimensions here for the x's and the y's. So we know that 2x plus 4x, put the x's together, plus 6y plus 6y, put these y's together, equals 48. And then it tells us the perimeter of the rectangle, remember the perimeter is measuring the outer edge, of a piece of land is 144 kilometers. So we know this one would be 9x plus 9x plus 18y plus 18y would equal 144. And now we just need to collect like terms. 6x plus 12y equals 48. The same thing here. 18x plus 36y equals 144. Okay, now we have two equations. And whatever the x is in one, the x will be for the other. And whatever the y is in one, the y will be for the other, since it's a system. So we just need to take these two equations and work it out real quick. And what method do we think would be the easiest? I think it would be easiest in this case. We have in standard form the x's and the y's equaling something. Just to multiply this top one by negative 3. Negative 3 times 6 would be, I'm going to write the answer just underneath this one, a negative 18x. A negative 3 times 12 would be a negative 36y. And some of you might already see something going on here. A negative 3 times 48 would be a negative 144. And we see that they all cancel. So when asking about the perimeter of these two places, even though they may not look the same, these shapes of land, but we can see they're the same. They're the same equation. They would be the same line if we were to graph it. So what would be the answer to that out of the three? How would you phrase it? Would you say there's one solution, they intersect, no solution, or there's infinite amount of solution because of the same? What would you say there? Okay, before you go, in your journals, I want you to write a system of equations that has no solution. Also, write a system of equations that has infinite amount of solutions. Good luck.